Alright guys, welcome to this page of the notes, and let's go ahead and do another graphing a rational expression. Again, this is one that I would expect you to be able to do if you're taking this class with me on a quiz or a test. Again, it's a free response question, so if you plug this into your calculator and draw a sketch, you're not going to get any points. Alright, I need to see the work. You got to be able to show me. Do you know how to find x-intercepts, vertical asymptotes, horizontal asymptotes, point discontinuity, right? You need to show me you know how to do all of that stuff. That's why it's a free response question. The points come from your work, not necessarily your final answer. Let's just jump right into this. This one, after that last one we did, which was really kind of a nightmare, yes, you'll still need to be able to do problems like that, but let's try one that's a little calmer. This one's not quite as hyper. So here we go. I give you this rational function. I want you to graph it. And I give you a roadmap. Start with the x-intercept. Well, we know the x-intercept is going to be whenever the numerator is equal to 0, and my numerator for this function is x plus 4. So we'll set that equal to 0, right? X plus 4? Yeah, x plus 4. Subtract 4 to the other side. Ooh, look at that. So it looks like I have an x-intercept at minus 4. Okay, great. Vertical asymptote. Well, vertical asymptote comes from setting the denominator equal to 0. Let's see, my denominator was an x squared plus 7x plus 12. Set that equal to 0. Now, I know, we had nightmares with this on the last problem. The last problem, we got a quadratic that was not factorable into integers, and it was because either you have x-intercepts that are decimals, or you have x-intercepts that are imaginary numbers, and we had to use the quadratic formula to figure that out. Fortunately, this one's not quite as crazy as the last one. I'll spot you the easy bit, x and x, but I think probably pretty quickly you guys will recognize, hey, 4 times 3 will get me 12, and 4 plus 3 will get me 7. So this is a plus 4 and a plus 3. Again, I need to solve those though, so I get x plus 4 is equal to 0, which means x is equal to minus 4. Yeah, and then I get x plus 3 is equal to 0, which means x is equal to minus 3. All right, we saw this on the previous page of the notes. When the same value shows up in both the top, or when it shows up in both the x-intercept and the vertical asymptote, it is actually neither. And we now know I have a hole in the graph. We have point discontinuity at x plus 4 equals 0, which means x is equal to negative 4. I have point discontinuity. PD at x equals negative 4. However, this one counts as a vertical asymptote, and since what I thought was an x-intercept actually turned out to be a point discontinuity, what are my x-intercepts? I have none. There are no x-intercepts for this rational function. Okay. Horizontal asymptotes. Here we go. The degree of the top and the degree of the bottom. All right, in the top I have x plus 4, the degree is 1. In the bottom I have x squared plus 7x plus 12, the degree is 2. Ooh, look at that. Here's what I've got. I've got ax is less than bx, and what that is rule number 2. It's been a while since we've seen this. Hopefully you guys remember. What does rule number 2 mean? Well, rule number 2 means that I do have a horizontal asymptote, and that horizontal asymptote is at y equals 0. That's what rule number 2 tells me. The x-axis is my horizontal asymptote. Guys, I now have all the pieces. I know about my x-intercepts, my vertical asymptotes. Where's my horizontal asymptote? Do I have point discontinuity? Let's put the pieces together and see if we can figure out this mystery. Here we go. First, vertical and horizontal asymptotes. Well, I have a horizontal asymptote that is the x-axis thanks to rule number 2. So, there's my horizontal asymptote. I also know, thanks to setting the denominator equal to 0, that I have a vertical asymptote at minus 3. Right there. Well, now we can see why my function doesn't cross the x-axis. my horizontal asymptote is on the x-axis. Remember, an asymptote is a line that your graph will approach, but never touch. Approach, but never touch. So, since I can't touch the x-axis, that means I can't cross the x-axis. Now, what does it look like? Well, you've got a couple of options here, things that you can try, but really here's what it is. Remember, the reciprocal function, the parent function, 1 over x, remember what it looked like. If I draw you a quick little sketch, you'll remember that it looked like that, right? Oh, sorry, that went weird. Like that, and like that. Okay, now, this one, right, will look exactly the same, but I just want to prove it to you. We can go ahead and quickly find, right, a point. Let's find a point. So here's what we're going to do. Y-intercept. Since I don't have an x-intercept, let's find a y-intercept. Now remember, you'll find the y-intercept by letting x be 0. All right, so y is equal to 0 plus 4 over 0 squared plus 7 times 0 plus 12, which means y is equal to 4 over 12, which means y is equal to 1/3. 1/3 is right about there-ish. Right about there-ish. Again, we're freehanding these, so it doesn't have to be perfect. Guesstimation, right? Okay, well, I have everything I need, right? Y-intercept, because I don't have any x-intercepts. I find my y-intercept to help me sketch this guy out. I can't touch the asymptotes, and I got to go through that point. There's only one way to do it. This guy's got to look like this. Through my y-intercept, don't touch those asymptotes. Awesome. Since it's going to positive infinity on that side, it's got to come from negative infinity on the other side, so that means it's got to be right down here. All right, so after the one we saw on the previous page of the notes, which was a rational function on steroids, that thing was crazy. We had quadratic formula running around. We had to do long division to find a slanted asymptote. This one seems very tame. That's just the way these go. Some of them will be really complicated. Some of them will be really pretty straightforward. You need to be able to do all of the above. I have several more examples. We'll get lots more practice. Head on over to the next page of the notes. We'll keep graphing. I'll meet you there.